Hi guys, how you doing? I got another plexus tutorial for you today. I had I had done one of these in the past, and it's right here, and it's called Lightwave plexus tutorial. And it's not a bad tutorial, but it's definitely more complex than it needs to be in order to get a plexus effect. And it's not even a true plexus effect because you have to first. It's just you have to watch it to see, but it's still a pretty good effect. But I had actually during a dream, I had a better idea of a way to do it like a proper plexus, like how it's supposed to be done, um, by just connecting points to points. And so I decided to make a tutorial about it. So here's what the finished result's going to be. And I took this one all the way through to completed render. So it's actually only the first 20 minutes that deal with doing the plexus. The rest is setting the rest of this up. Here's another one I did with a skin shader. It took longer to render, but it's nice that the dielectric and the skin, they all work on here, which is nice. But this is the final effect. Um, the other thing is too, Dennis updated the Army and collection nodes because I had found a bug with the one node that I was using. It just when you copied and pasted, it was losing its settings. So if you're going to use warping, like I do in this tutorial, either watch copying and pasting it, or just go update your nodes. But that's about it. So let's just get started. So the first thing we want to do is create a 2-point poly line. So I'm just going to create a 1-point poly, and then extrude it 1 meter. And it has to be a meter. That's important for this whole setup to work. Well, it doesn't have to be, but you'd have to account for it then. And I'm just going to give it a surface of line. And then in the next layer, I'm going to create a platonic solid, and I'm going to create a octahedron at 1 meter side length. And then I'm going to take all the points, and I'm going to use rounder on them in point mode, and with one point, and I'm going to round it at the square root of 2 divided by 3. And that'll give me a truncated octahedron. I just like using these for the connections. I think they look cool. It's probably my favorite Archimedean solid. I think that's what it's called anyway. So that's pretty much it. I gave it a surface. Now I'm scaling it down. And that's pretty much it. So that's it for that. We just have the line and then the connection. Okay, so now what I'm going to do is I'm going to create a particle emitter, and I'm going to go into the properties. I'm going to put birth rate on 10 by the speed. I'm going to take the generator size down to 100 millimeters, and I'm going to put the limit on 100,000. I'm going to make the weight off set to 2.2, and then the resistance to 0.5, and then the lifetime to 45, plus or minus 15. And then the explosion I'm going to put on 0.6. No parent motion. And that's pretty much it. So now what I'm going to do is I'm going to add node motion to that particle emitter. And what I'm going to do here is I just want to get some random fluid motion. So I'm going to get Army and Collection 3D texture, simplex noise, and I'm going to plug the bump into the position. I'm going to turn the bump amount up about 3,000. And I'm just going to get a multiply. And going from the time, I'm going to multiply it down to 0.5 and go into the offset. So I'm going to lengthen the frames to 300. Now you have to calculate it to see the real motion, but I'm just moving it a little bit to try and get different motion out of it. Okay, so I'm pretty good with that. It's just a quick way to get some random fluid motion. So I'm just setting the camera up so we can see it. I'm just trying to center it on there. And then I'll calculate it just to see what the particles look like. That's good enough for what we're doing. So that's pretty much it for the particle emission. And the nice thing about this effect is that you can use any amount of particles. The particle could be changing. That's the good part about this setup. So I just saved out this PFX file. I think if you're going to be able to do a plexus, the best way to do it is on a particle cloud that has changing points. So this is a good way to do it. So now I'm just going to load that line, the first layer, that line object, which was the line. And you can see it there at the origin. And I'm just going to turn it off so it doesn't render. Then I'm going to add instances to it, DP instancer. And we're going to turn the step size to 1. We're going to select that object and add it, put it on grouped and pivot. And for now, I'm just going to put the instance number to 200,000. That's going to change though. So now all I'm doing is I'm getting the first frame where there's only a couple particles, because that's the easiest way to see what's going on when we're setting this up, is to have a small amount of particles so you can see what's happening. So the first thing we want to do here is get instance generator, instance info, and that'll give us the index. Then we want to get a item info, particle info, and we want that to be emitter and indexed. It's important that it's indexed. And the same thing for the other one. And then we're going to get one more. We'll keep it the same, but we're just going to use that one for the count. That's important too for this, to get the changing particle count. So we're going to get a mass scalar add, mass scalar divide, mass scalar floor, and a mod as well. And that's what's going to, we'll basically just do a nested loop through these, through this index. So I'm just going to add -1, so we start at 0, because that's what the particle info starts at. And then we'll go into the divide and the mod, and then we'll divide and mod by the count, and that's what allows us. And the count's 7 right now. I'm just showing you so you can see how this is working, and you can see all 200,000 instances are being drawn. If you look at so now I'm just dividing by the count and modding by the count. And the maximum length we're ever going to need this loop to be is count times count. So the first thing we can do is multiply them together, and we can get a logic, and we can just say if the index is greater than the count, if A is greater than B, then we want it to be true to be 0 and the false to be 1. And now you'll see if we go into the enable state with that, it'll automatically cut down the instances to the 49. So there was 7 times 7. But we can even cut that down a bunch more as well, but I'll get to that in a minute. So the next thing we want to do here is we're just going to go into the index with the floor and the mod. And if we go from the position into the position, that'll put the instances on there. And we can get a vector distance. get the distance between, and that'll scale them the length that we want them. And you can see there's it scales them to the right length. And if we get in line 2, it will align 2 from the first one to the second one, and you can see then that pretty much gives you the plexus effect. But that's with every one connecting to every other one. So you want to have a condition on that. So you'd want to, well, the first thing to keep in mind is that right now we have twice as many instances as we need. You can see if I take the scale down to 0.4, you have one pointing at the other in both directions. So that's twice as many as we need. And I was just going to scale it to 0.5 and leave it, because you still wouldn't be rendering anything extra, but you'd be having twice as many instances. But I thought there might be a better way, but I couldn't figure it out. So I asked Dennis how to do it, and he was nice enough to give me the solution. But I'll get to that in a second. The first thing we want to do is we want to clip the ones that are above a certain distance and have a scale of 0. So that's why I went from that into this double logic here. So we're going to say if A is less than B, which is going to be some set distance that we put in there, and not equal to 0. So this one's going to account for ones that equal 0, the distance equals 0, and is above this distance that we want. So I'm just creating a scalar for that distance that we're going to set. And I'm going to just add a null, call it slider. And I'm just going to use a slider for this distance, because I feel like that's the easiest way to deal with it. So if we go into the settings, I'm just going to add that scalar that we just created. So now this scalar from that node network will be controlled by this slider. It just makes it easier to control this way, because we're going to use this for another part of this. It just makes it easier. So we're just going to label it distance, give it a color. So now if we go back into the nodes for that, we can finish this up. So now you can see right now it's set to a large amount, that number, so it's not going to change. But you'll notice once I go from the output of this second logic into this false of the first one, it'll drop off the instances that are pointing to itself. So that should drop 7 instances off. So that brings us down to 42. Then the scalar here will take down any that are within a certain distance that we just hide. So you can see if I scroll through this, it'll only draw the ones that are less than the distance that we're putting into the slider. So that's how we can get the distance threshold on it. But so we're still drawing twice as many instances that we need. We're not rendering more because the way I only have them scaled by half, but it's still not ideal to do it that way. So what Dennis suggested, and I couldn't figure it out, was to just take the mod here into A and the floor into B, and then just say if A is less than B, have it equal 1, and if not, equal 0, and just take that into the back of the other one. And you can see now it cuts off half of the instances, and you can see it's only drawing half. But if you scale them by full, then you're getting the exact same thing. So this is with no extra connections at all. It's real efficient to render this. And the shading's real good. You don't have to worry about it messing up because you're not getting any extra connections at all. It's just the connections needed to create the plexus. So that's pretty much all there is to it. It's not that much compared to the other one I did, which was so many more nodes. So you can see we can control the distance. Now, one thing to keep in mind is that you'll notice what happened to it. And that's because we don't have enough instances. So the way that you could tell how many instances you're going to need is that you would need to do this count. Whatever the maximum count in your scene is, you're going to have to do a couple places and check. You want to 2 times that. So it would be 1,500 times 1,500. So you just want to square the maximum count that you have in your scene at any time. And I put it down to 1.9 million here, but I ended up having to change it because I didn't realize there was more particles than I thought in one spot. But you can see now we can turn the distance up and down. It's lagging a bit because of there's so many. The way you would want to do this, I'll show you in a little bit. After you get everything set up, you would want to just turn the instances off, so you don't the preview off, and turn the drawing on the refresh. I'll show you when I get to that. Okay, so I just loaded that truncated octahedron, and I'm going to do the same thing here. I'm going to turn it off so it doesn't render, and I'm going to add DP instancer. Turn the steps to 1, add that object to itself, add selected object, grouped, pivot, and I know that I don't need any more than 1,500. So what I'm doing here is I'm just turning these off, the other ones, so I don't have to deal with them while I'm dealing with these other instances. So I'm going to turn the limit to 1,500, and we can go into the nodes. And we're just going to get the instance index, or we'll get the, what do I get? Yeah, instance index. And then we'll get item info, particle info, and get add y -1 because the particle starts at 0, instances start at 1. So now if we go, I'll select the emitter, put it on indexed. If I go into position, you'll see it'll put all of our truncated octahedrons on the particles. But you'll see we're drawing all 1,500. And you don't really want to draw them because you'll have overlapping ones. So what you do here is, if we just get a logic here, we'll just clamp it the same way. You just get the count, and if you get the index, if the index is greater than the count, then we'll have it be 0, and if it's not, we'll have it be 1. And you'll see if you look at the instance number, once you plug that in, it'll kill the instances over the amount of the particles that we have. So it's only going to draw how many particles there are. Now, there's one other thing we have to keep in mind here too, and I'll show you that right now, and that is the fact that I'm dragging that slider. That's why it's taking a minute, because I'm trying to show you that, because right now we're drawing all the I'm trying to show you so that you'll see what I'm talking about. See how we have, when you're not drawing all the lines, or when the distance is shorter, you're still drawing some of those. And I also noticed that I didn't have enough instances on that 1.9 million wasn't enough. So I'm going to fix that real quick. So I'm just going to go into that other instances and put it on. I'm going to try 2 million. It's because I didn't go through the whole animation to see what the maximum number of count was, so I guessed, but I didn't guess high enough. So 2.5 million ended up being enough for the whole thing. So now, going back to what we were doing, the way we can clip these extra octahedron is we can get another particle info, And we're going to put this one in nearest mode because that's the only way we can get access to that between is when you're using it in nearest mode. And I'm going to get a replace spot, and I'm going to take that between into the alpha. And what that between is doing is giving us the distance to the closest particle to it. So if I get a logic, I can basically use that same amount that we used in the other one to clip those as well. So if I take the alpha in the A, and I'm going to use the distance from our particle as the world spot, because you got to remember, as far as this node editor is concerned, all our instances are at the pivot. So we have to tell it where our instances are, and that's what that replace spot's doing. Now I'm getting a channel info, and this will just give me any channel I want. So I'm just going to select that one that we're controlling with the slider, and I'll just take that in the B. So basically, we're just going to clip those octahedron with the same distance threshold that we clipped the lines with. So if A less than B, I want it to equal 1. If not, I want it to equal 0. And we'll take that right into the back of the other logic, and you'll see that'll clip off any more than what we have with the lines. So we're just using that same distance threshold. You can see when I unplug it, they come back. So you might want to do it either way. That's why I showed that, because I think that's important to know how to get them to only show up when you want them to, or if you want them to. So you can see how it updates it. Okay, so now I think what I do here is deal with the rotation. So I'm going to get a turbulence 3D texture. And I'm going to take the bump into the rotation. And what I'm going to do is use the start position from a particle as the position for the turbulence. So that'll just mean the initial rotation of these will be varied by this bump procedure based on where they started from. So they'll all have a random rotation, basically, which you can see they do. And I'm also going to take the scale down to 50%. So that's pretty much it. That's really all there is to it. Now I'm not going to use those octahedron in the effect I'm doing. I'm going to go for more of an organic look. But so I'm just going to clear them from the scene because we don't need them. And I'm also going to delete these keys that I made by accident in this slider and just put them all at 0.125, the distance. So that's what we're going to go with for the distance threshold. I mean, you could change that, but I'm just going to leave it fixed for this animation. Now, what I'm doing here is I'm turning the display for the instances, I'm turning the display to none and the update to refresh. And this will cause us just to not have to worry about drawing them at all. I'm going to turn the camera at 50 millimeters. So we're just not going to draw the instances at all unless we're rendering. It'll make it easier to work with. I'm just trying to put a little bit of a camera animation on here. I'm adding a node called cam control. And I'm just trying to put it toward the center of where this animation is. Just because I'm going to rotate the camera make the camera the child of this. And then I'm going to rotate it. So I'm just trying to get it pretty much close to where the center is. Make the camera the child of it. And then I'm just going to rotate it over 300 frames, about 71 degrees, negative 71. And then I'm going to go to the camera, and I'm going to back the camera off and just kind of put this in the view I want it to be in. So this is the animation I'm going to go with. I just wanted a quick animation to do this effect with. I was kind of pleased. I actually like the way the motion of the particle emitter is. Okay, so now I'm going to load in a backdrop image. It's just one that I downloaded. I want to put the anti-aliasing, the softness. That becomes important for later. I'm going to add a texture background. Just going to use that as my backdrop in spherical on the Y. I'm going to turn mip mapping off because it doesn't need it. And then I'm going to just adjust these camera settings a bit and turn oversampling to 1, turn on global illumination, backdrop only, 4 samples, turn off ray tracing, transparency, and refraction. Just adjusting these settings here. I turn the recursion down to 2 as well. Just trying to keep this rendering as fast as possible. So now you can see now those lines aren't being shaded because of the way this is set up. But I do demo what it looks like without, I'm turning off the light so the light isn't affecting this, because the light was also affecting it. So now I kind of do like the plexus effect with this solid color like that, but for this one I'm going to use shaded plexus because I think that could be cool too. So what we're going to have to do is go into the edges for that object. And we're going to turn the edges to negative 0.02. And you can see that now that'll be the largest that our edges will be. But what we're going to do is we're going to go into the nodes for the edges. And we're going to get a gradient, and we're going to set it to Z. So we're just going to use, because remember our line goes from 0 to 1 on the Z. So this gradient from 0 to 1 will determine the profile of our instance. So you can see I'm just setting it up here. I'm leaving the two ends at 100, and I'm just making it a little bit skinnier in the middle. So you'll see what the effect it gives you when I render it again. So if I take the alpha into the taper, I go into the VPR, you can see it gives a more organic effect. And then in the next tutorial I do, where I'm going to use just a point cloud to do this, I'm going to do something with that's a little more organic, but this is still pretty cool too. So I'm going to go with that for the edges. Now I'm going to go to the surfacing for the line. And I just do a quick surface here just to give it, so I'm trying to go for like a printer, like 3D printer, PLA type of look on this. That's what I was going for anyway. So I'm just going to use this Chandlum. It's like a subsurface. It's kind of like a cheap subsurface node, but it works pretty fast. So I'm turning my ambient down to 0, and my light's already off. So I'm going to turn the strength to 1. I'm going to turn the sample radius, and this will be like the distance of the surface, how far it penetrates the sample radius. And you can see if I go into the diffuse shading, it gives a pretty nice subsurface effect without having to use ray trace transparencies or anything like that. So, but that's only giving you the absorption look. I do want to get some surface diffusion on there too, so I'm getting a regular Lambert shader here, and I'm probably just gonna just mix between these two. And I'll probably just let the Lambert shader show 25% and the subsurface show 75%. Just because I want it to have some surface diffusion where it's not just all being absorbed. It's not really how it would look in real life. So now you have the absorption, but you also have some of the surface diffusion as well. Okay, so now I'm going to go into the image editor, and what I'm going to do here is I'm going to clone this image. And the reason I'm doing this is because I want to use this image as a reflection map. But in order to get it to match up perfectly with the backdrop, what you have to do here is I'm going to add a pixel node image filter. I'm going to get the render buffer node, and I'm going to get a scale node. And I'm just going to scale the image horizontally by -100%. And what that does is that flips the image horizontally and makes it so that your reflection, when you use a reflection map image, that it matches up perfectly with the backdrop image. I don't know why they made it like that, but that's the way it is. And I'm also adding a slight blur to the image, just because I want these reflections to render as easily as possible. I'm also going to use ray tracing as well for reflections, but I want to use this for the backdrop because there's some pretty hot spots, and this is an easier way to clean up the backdrop than having to throw samples at it. So that's all I did for that. So now what I can do here is I want to go into the environment. I want to put it on ray tracing and spherical map, blurring at 3, reflection map, set it to the flipped image. Go to the advanced. I want the highlights, color highlights to be at 50%, because I feel like when something's absorption has a lot of light absorption like that, it also tints the reflections a bit. Now I'm getting slicks approximation from DV&W, facing 20, glazing 95, exponent at 2. We'll go with 15 for the facing. And that color needs to go into the color because that's what controls the tint if we use the tint reflection. So I'm going into the reflectivity with the reflection. And if I just take that inverse and scale the color with it, that will kill the diffuse based on that slicks approximation. So it's keeping it kind of like energy conserving. So where it's more reflective, it's less diffuse. And that's good enough for now. I may mess with it more, but I'm really not trying to get too crazy with this. Just wanted to have like a nice effect for the tutorial. So what I'm doing now is creating a 1 kilometer sphere centered at the origin. And I'm going to go into the render for that, turn the shadows off, and turn everything off except unseen by camera. So this is only going to be seen by the camera. Turn on smoothing, double side it, luminosity up, diffuse down. We're going to turn it off and open GL here. What I'm doing here is I'm just turning off the instances because I don't want to have to deal with them while I'm shading this background. So now we just have this background sphere that I can surface, and we're going to use this as the backdrop. So I'm just getting an image. I'm going to select the original image, put it on Y in spherical, raw coordinates. And if I go into the color with that, that'll map it on the sphere. But you'll notice that if you go into VPR now, if I turn off that object so you can't see it anymore, it doesn't line up perfectly with the backdrop. See how and that's because of our camera motion. So the way we can fix that is we're going to get a item info, and we're going to select our camera. We're just going to put that into the position for the image, and that'll make it so that it lines up perfectly with the background. It wouldn't really matter too much with this animation because I'm going to blur it real bad, but in other cases you might want to, you'll notice now when I click it, turn it on and off, it matches perfectly with the background. And that's because we had camera movement. Another thing you could do would just be to link the movement of the position of the dome to the camera, but I like doing it this way better. So I'm just going to blur that by turning the bitmap up to 75, and that'll blur out the background real bad. Now I like doing this because it's an easy way to get a nice volumetric environment that's based on the lighting that you're using. So what I did is I got a warping. That's R-Man 3D texture and a mixer. And I'm just going to take the alpha from the warping and multiply it over top of the image. Just going to set this mixture to smoke 2, frequency 2.2, 200 meters on the X, Y, and Z. And you can see that gives a real nice 3D procedural smoke. I really like these textures. That warping, they're real nice textures in there, especially for this kind of thing. I'm just going to multiply that over the image. So you can see that gives us kind of like a nice volumetric smoky environment. And now what I'm going to do here is I also want to kind of distort this background image with this warping as well, but I'm going to make it a lot bigger so it's not so drastic. I just want it to look like that the background's being distorted. I'm going to turn the frequencies down. And I'm going to get a add, and I'm just going to add that to the camera position. So you can see now if I turn this, as I turn this bump up higher and higher, you'll start to see it warping it more and more. You have to take it pretty high because the texture's scaled pretty big. But you can see as I start getting up into 10 million%, you'll start to notice it more. See, that's kind of, I don't want it that drastic, but that's what I'm going for. I want to have the background warping like that a little bit as well. But I'm going to take it down to like whatever I end up doing. I think it's like 15,000%. And that's just because that texture is scaled up so big. That's probably good there. And what else I'm going to do is I'm going to animate this offset just so it looks like it's kind of in motion a little bit. Not a lot, so it's noticeable, or not a lot noticeable, but I just like it. It kind of goes with the flow a little bit if there's a little motion to it. It's almost imperceptible, but you'll see when I put the other smoke over top of it, it kind of makes a nice volumetric type of environment. So now if I just go back in with the, I want it to overlay smoke. I'm just setting my viewports to have three viewports, just so I don't have to render it so big. And now what I'm doing here is I'm animating the offset in that other node as well. And I'll show you what the offset's doing. You'll be able to see it in a second because I do a preview. So if I do a preview of this, I think I do. So you can see what it's doing, the offset. See how it kind of makes the smoke look like it's billowing? Keep in mind this is playing back at 125%, so it's not as quick as that, but that's the effect that it's given. I really like that warping node a lot. So I'm going to turn my plexus back on here. Now what I want to do is I want to add some fog to this, and the way I'm going to do that is I'm going to, because I want this to render quickly. There's other ways you can use real volumetrics, but I think for this I'm just going to go with a background fog type thing. So I'm just going to copy all those nodes, Go into the volumetrics, going to turn on fog, realistic, and open the texture editor. And I have it just set so it's full fog color now. There's no fall at all. You're just getting the full fog color. I'm going to add node texture. Go into the node editor. I'm going to paste those nodes. Now you have to keep in mind the textures, or the one for the background, scaled way more than it needs to be. So I'm going to adjust for that in a second. But I don't need this to match up exactly. I don't want it to be exact. I just want it to be very close to the background, because I don't want it to look like the background's being projected onto it. I just want it to look like that it's in the same environment. So I'm just taking that first warping down to 2. And I'm going to take that bump down to 100%. Probably even go lower than that. I think go 50% with it, because I don't really need that texture to be that much. That's the texture that's displacing the background image. So, and I'm also going to take the speed of that animation down to 0.2. And then for the other warping, what we're going to do is we're just going to take the scale down on that as well, to like 0.5. Because like I said, I want it to look like it's in the environment. I don't want it to match the backdrop exactly. And then I'm going to take the texture down to, or the speed of that offset down to 0.2 as well. So you can see now we have this fog it's similar to the backdrop, but it's not exactly like the backdrop. But it works good for the look that I'm going for here. So now I'm just setting up the min-max distance for the fog. So I'm just going to like right before where the animation starts to right after it, like the closest and the farthest. So that should be good. So now you can see the fog effect, what that gives us. Now, the next thing we got to do here is I'm going to set this up for open image denoise. So what we got to do for that is add pixel filter, and I'm going to put on the normal color, get a render buffer. I sped this up a bit. Going to take we got to turn on the extra buffers, the global buffers. I'm going to take the normal into global buffer 1. So that'll give us the anti-alias normal that we need for open image denoise. And now I'm just adding compositing buffer and showing the RGBA. So I'll be able to see the image before anything gets done to it. It'll display both images. And then I'm adding the image filter, and I'm going to turn on the RGB, raw RGB. And I'm getting a render buffer node, and I'm getting the global buffer. That's our normal that we just created. And I'm going to get open image denoise, and I'm going to go into the color. Now I am going to denoise those buffers because I'm going to use pretty low settings here. It's just setting this on HDR. So I'm just going to denoise the raw RGB and go into the albedo, and then denoise the color, or the normal, and go into the normal. And then I'll go into the color. And then I'll use clean auxiliary buffers. When you're using real low settings, I feel like this works better. So now we'll do a quick test render, just to see how the noise filter is working. I'm just going to put it on 8 samples. Turn the shading samples up a bit. So that took a minute and some. You can see the before and the after. So that's pretty much it for that. Now what I want to do here is set up the post-processing. So I'm just going to open Viper so we can see the preview. I'm going to go through this pretty quick. I'm just checking the buffers to make sure they're properly, the normal and the raw RGB, just to make sure they were right, which they were. Then I'm turning off my temperature monitor because it gets to be annoying when using the open image denoise. So I'm going to add a bunch of these nodes for the post-processing. I'm going to add a mixer, fast tone map, vignetting, grain, dispersion, camera response, and bloom. And like I said, I'm just going to go through this real quick just to get a final shot going. I'm going to turn it to manual so it's not trying to update it every time I plug something in. So for bloom, I'm just going to go to 30% threshold on high quality. Then we'll go into the tone map. I'm going to do, I forget what one I do, Lots. Then I'm going to go into the camera response. And I'm going to pick this Ektachrome 100. I'm going to turn the exposure up to 2.5. And that's pretty much what I'm going to go with. I'm good with that. I could have messed with it more and more, but it's just a tutorial. So I'm turning the dispersion, the vignetting, and the grain on here. The grain I set to 20. Use the camera lens for the vignetting. Dispersion to 1%. You don't really need any of them. You could do whatever you want to do, but so that's pretty much it. So I'll do one more test render so we can see the difference between the post-processed and non-post-processed. Alright guys, so that's basically it. I'm going to do one more that's going to just deal with a point cloud, and it's going to be more of like a growing neurons type of effect. We'll get some displacements in it. But the only thing I would do with this, if I was going to render this out for animation instead of a still, I would take the samples to 1, put this on fixed, and put the motion blur on motion blur, and then use like 16. And that'll give you good motion blur with this, which for the animation you would probably want. You could use classic as well. I didn't check to see which one was faster or even looked better, but it's probably classic's probably faster. But so that's pretty much all there is to doing it. So I hope he's got something out of it. Take care.